As our study of derivatives and how a function behaves, we want to revisit limits here momentarily. So I want you to pause the video and find each of these four limits. Resume the video when you have an answer. And here are the answers. Okay, most of this should be old hat. Just remember that when you're simplifying limits, you always need that notation of limit as x approaches or whatever variable approaches in there. Okay, but the last one, when we solved this, we did a bit of well, we used properties of rational functions and we found the horizontal asymptote, right? And also in there, we said some strategies to solve that were to look at the highest power. And so initially I had introduced, limit as x approaches infinity, or that this is approximately the same as the limit as x approaches infinity of x squared over x squared, and then we use that to solve too. So that was a little hand waving, right? When we initially substitute this in though, right, don't we, if we try the direct substitution method, right, we would get something like infinity over infinity, okay? And when we do that, that isn't a valid limit because infinities are different. Or can be different, I should say. And so when we talk about this infinity over infinity idea, that is called an indeterminate form. Okay, so the rational indeterminate forms we get are infinity over infinity or 0 over 0. So you could also have a combination 0 over infinity, etc. 0 over infinity would be 0, but then infinity over 0, what is that? So we have to think about that too. So, and I'll also mention these can be plus and minus. Okay, there are difference that are indeterminate as well, and then we have power indeterminate forms. So in each of these cases, what do? We can actually still find the limits, but we have to use a different method, and it is called L'Hopital's rule. It looks like La Hospitals. It's this person was French, and so it's in some books you even see like it's La Ho and then like a little accent over the O. L'Hopital's rule. Okay, so it isn't La Hospitals. Okay, do not say La Hospitals. But the idea with L'Hopital's rule is that you have f and g as differentiable functions. Okay, and we have to have g of x is not 0. Okay, when we look at their limits individually at or near a, they are either 0 or a form of infinity. And then when we look at the ratio of them, and so typically when we work with L'Hopital's rule, it is going to be a ratio, but it doesn't need to be. What it says is that we need to once we realize that it is an indeterminate form, so you have to verify that it is indeterminate form, then all we have to do is take the derivative of the numerator function alone and denominator function alone and compute that limit. And if that doesn't exist and it's still differentiable, do it again and again and again until you get a limit. Okay, that's the idea of L'Hopital's rule. And just again, need to verify it's indeterminate first, and then you can also use this for one-side limits and limits at infinity. Okay, the proof of this theorem is actually kind of interesting, and it uses the extended mean value theorem. So that's kind of why we're connecting this with the mean value theorem lesson. So I'm not going to go through the video go through the proof in the video. It isn't too long. I did post a PDF of the proof for you to follow along if you're so interested. Otherwise, in the next few videos, we'll get some more practice with L'Hopital's rule and indeterminate forms.